SunTrust Bank, one of the nation's largest banks, gave us this opportunity to work on developing a text mining framework for helping predict potential client attrition. By a preliminary analysis of the blind data with no client identifiers, we identified that the average revenue of clients was very high, which implies that each client is an asset and retaining each one matters. We also encountered inconsistent text in the conversations and several thousand abbreviated words, and identified several specific words and phrases related to client attrition. We specifically focused on analyzing textual content from documented conversations. The three primary approaches that drive our analysis are term frequency, inverse document frequency, deep learning using neural networks, and latent directlet allocation. Term frequency inverse document frequency, or TF-IDF, is an algorithm that is based on the frequency of each word in the documents, allowing a simple, efficient, and flexible metric for weighting the words and extracting the most relevant terms. It also lets us compare documents easily by finding unique frequent words. Another method we use to evaluate the text is sentiment analysis. This approach identifies the writer's feelings expressed by positive or negative words in a sentence over time. Sentiment analysis can capture meaning across words. For example, the word don't in the context don't care will change the meaning of a sentence to negative. It is also a faster way of getting insights from the data at a lower cost, since it doesn't require a model, allowing us good accuracy from the beginning. We also identified a set of words that uniquely exist in the documents from clients who have attrited. The second approach we use is called deep learning. Deep learning allows us to recognize patterns from the data, including text and images. When given an image like this, our brain starts guessing by observing various features like shape, color, and size. It then tries to relate with what it has seen so far and identify what the image shows. In this case, a leopard, or a cat, or a lioness. This concept was mirrored in convolutional neural networks. This is used on text to find patterns and classify the clients to decide if an account should be flagged for possible attrition. In our case, we have achieved a good accuracy and predictions are near instantaneous. The third approach was the text modeling technique called latent directlet allocation, or LDA. Topic modeling algorithms are statistical methods for identifying the underlying topics from a collection of documents. These topics are bags of words that have different probabilities of appearance in the topic's discussed corpus. While the topics generated are able to summarize the corpus pretty accurately, the topic modeling gets affected when the discrete information lies in the unaccounted words and topics. To prepare our dataset for modeling topics, we use open source tools like Python and R to execute natural language processing techniques like tokenization, stemming, and lemmatization. Once the data is cleaned, we use LDA on data from attrited clients to extract the most prominent topics that led to attrition, and use logistic regression and random forest classification models to predict the likelihood of attrition for a client. This comparison, however, only gives us the probability of attrition for a client in the next year. We also implemented a temporal LDA, which gives us a more accurate estimate of how far a client actually is from attriting. We were focused on minimizing the false negatives, in other words, clients which are incorrectly predicted to not attrite within the next 12 months. We are able to predict attrition using this text model with a very high recall and average accuracy using this approach. On behalf of Georgia State University and the Institute for Insight, thank you. We appreciate the chance to participate in this project and to understand how techniques from machine learning and statistics can be used to solve a real business problem.